Okay, so another question then that I got from a student was homework problem 1720. Again, it's evaluate the commutator. X bar and p squared x bar. Okay? So what we've been doing here is we've been saying what are some other ways that this question could be worded. One is, do these operators commute? That's another way that just it's the same question, right? Do these operators commute? And the answer, of course, would be yes or no, but how would we tell if they commute? How would we tell? You need to know that. Evaluate the commutator. Another thing could be, can these measurables, or I'm sorry, observables that go with these operators be measured simultaneously? That's another way we could ask that. So, all right, be thinking about that. Now, what are some other ways we could ask the very same question? All right, evaluate the commutator. Now, again, we need to say, what if that's the operator, what is the, if that's the symbol for the operator, what is the operator? And the operator is simply multiply by x. Okay, but what about this one? P sub x. Now, I realize this is squared, okay? But if this is P sub x, that is the momentum operator. What is that? And it's minus I h bar d dx. Okay? And then the final thing I want to review before I begin this is what is a commutator. And the commutator is expressed like this. A hat b hat is equal to a hat b hat of some arbitrary function minus b hat a hat of the same arbitrary function, right? And then, of course, ultimately we factor out we don't factor, but we know that is interpreted as a hat b hat minus b hat a hat. And that's what the commutator is. That is the definition of a commutator. All right, so that said, we take these two commutators, and I'm going to write this out. I'm going to say, and hopefully I'll give myself enough room here, this is x bar, which is x times minus I hat, minus I h bar d dx, and this is squared, so I do it again, h bar d dx, some arbitrary function, okay, minus I h bar d dx minus I h bar d dx x of that arbitrary function. Okay, so we'll operate this down the page. Now, first of all, these two here, these are just constants with respect to x. Okay, so I can pull those out front. And let me make a note about this. Minus I h bar squared is the same thing as minus I squared h bar squared, which I guess is the same thing as minus 1 squared I squared h bar squared. Okay, I say that because it's an easy mistake to make, and I really want to work this out. What is minus 1 squared? What's plus 1? What is I squared? Minus 1. What is h bar squared? Well, it's h bar squared. So this, if I pull these two out front, this is going to end up being minus h bar squared. Okay? X d dx f. That's this whole first term. All right, and we're done with that. That whole first term is here, because I pulled those two out first and put them right here, and then I took those two functions. This is an arbitrary function of f of x, so we can't actually differentiate it, but we can say what it is. It's the second derivative of f with respect to x. That's what that is, and it's x times that. All right, so that part's done. Let's come over here now and say this. Now, if I'm going to take these guys and bring them out front again. All right, and I'm going to envelop it with that minus also. Now, those two squared gets to be minus h bar squared, right? And then minus times a minus is, of course, a plus. So I'm going to say plus h bar squared. And now what we've got is d dx xf. Okay. I'm going to keep going down the page on this one. Now, the first derivative of x and f, I have to use the chain rule. Right? Because it's two functions of x. One is just x, and the other one is f of x, which I leave the f of x, I leave the parenthesis f. Right? I've said that in class several times, that f is going to be f of x. The reason I'm leaving it off there is for simplicity's sake, okay? So let's go back up here and say, this is two functions of x. X and then f of x. All right, so I have to use the chain rule. I'm leaving these parts the same, but now I'm going to say this is dx times f plus x times df dx. That's just the chain rule. Okay, I know I'm doing a lot of extra pencil strokes here, but I got to keep this simple for myself. So this just goes to 1. So this is just f, right? Because that's 1. And this is x df dx. All right, so this looks like this is h bar squared df dx plus h bar squared df dx. Oops, there's an x in there too, sorry. X df. Oops, sorry. Crud. Okay, made a mistake here. Now we're going to do the derivative of this. Okay, this is derivative. And derivatives are linear, so I can take the derivative of that and just say that is that plus that. Okay, so let's do it again. Sorry. This is df dx, and then derivative of that, I have to use the chain rule again. This is going to be dx dx df dx plus x d dx f. Right? There's two functions of x here. One is x and the other one is df dx. So I've got to do that twice. That's the chain rule. That's my feeling is if you're getting lost, maybe that's the part right there. Boom. Okay? Ask about that if you want to know. All right, now that we've got that, we just take the h bar squared and multiply it times all those things. H bar squared df dx plus, that's just 1. So this is h bar squared df dx, right? Because it's h bar times all of that. This becomes 1. And then this is h bar squared x d f. Okay? Now, this was just this downside. Let's bring this guy down. Minus h bar squared x d dx f. Okay? Looks like these two guys, just brought that down. I think that was off camera. You might want to pause here. If too much of that was off camera, you might want to pause and catch up with that. All right. So, but you see these two terms, one's positive, one's negative, so they cancel. This then becomes 2 h bar squared df dx. That's the commutator. That's the whole darn thing. That's x hat p hat squared. That is the commutator right there. Okay. Hopefully that's helpful. That was a little complicated. Easy to make mistakes in there. Good luck. Let me know what you need.